Unit 18, Part 6.
Daddy, what happened to your beard? Your beard fell off.
I know. I tried to get through the whole course on one beard, but I failed miserably and it fell off. Hi, son. You can't be on camera because you're naked.
Dada,
Yes.
you forgot to put a cream in the office.
Here, take it. Thank you. Can't show you on YouTube. You're naked. All right. Thanks, Aiden.
No, I'm doing.
Okay, you can walk around. All right. I'm also going to do this exercise.
Can you put my shirt and pants?
No, I can't. You're going in the bath. Hello.
Hi.
All right. I want to do logic. Okay. So I'm going to do this problem. Otherwise, I have to delete it, and our joke will be ruined. All right. It was perfectly set up. Okay. I'm going to do this problem from part number C, from 3:45 to 6. So I have been stressing throughout. Here you've got the beginning, and this is all one problem, the beginning and the end of it. Okay, so you should try this yourself and read through how Klenk works through it. Starting at the bottom of 3:45. Now, I have been stressing throughout the importance of working backwards, right? That's the mantra that I've always been saying you should adopt. Remain conclusion driven. Let the form of your conclusion determine what you do.
Same thing that you did to Eden.
I cannot right now because I'm on camera.
Yeah. I'm coming.
Thank you. And I think that Klenk really doesn't stress enough how crucial it is to be working backwards. The place in the entire text, the entire book, that you really comes close to stressing the importance of working backwards, to my satisfaction, comes in how she works through this problem. Okay? And so I'm going to read you here the first few moves she explains at the bottom of 3:45 as she works through C. Okay, so just before this, she said, right, just before the presentation of C, she says, in plotting strategies for relational proofs, it is especially important to use the method of working backwards. This is what I always say: determine the form of the conclusion, decide what you will need to get it, what preliminary steps you will need, and so on. Let's take a complex example. Let's see. But now look at her first few steps and working it through. It's clear, working backwards, bang, 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 in order to determine exactly what formula you need to get your conclusion, applying the same thought to the next line, identifying its form, determining what you need to get that, and letting that determine your next move at every step. And you will see how what drops out of applying the working backwards procedure here is the crucial information. The information that I stressed was the crucial information when we worked through A and B in the previous parts. That is, resolving your choice for the universal instantiations, especially your choice of what individual constants to instantiate to, and to replace the universal quantifier with which individual constant, right? So those choices are determined, right? So the hard rules like existential instantiation and universal generalization. So just think of existential instantiation. You are determined to follow the rule. So you're the one who you've got to follow the rule, which means if A has already appeared, and you're now instantiating, getting rid of another variable, you have to instantiate to B, right? You're determined to do B, to instantiate to B. But universal instantiation, you're not determined, and that's why it takes a little thought to get to which instance you want to instantiate to, and how do you go about resolving that choice? As I explained, working through the other ones, it's by matching, right? And by matching, for example, it's going to be, we'll work through these few steps. This will be me just reading through and showing you how it appears on the page, the few steps she works through at the bottom of 345, illustrating the working backwards method the best way she does in the whole book. And look at what will happen. Our y and x here in our conclusion get the specific a and b here, right? So that will be the information which tells us when we come to instantiating, especially doing our universal instantiations, what do we want to replace our x with, a or b? We'll get the information by matching. What do we want to replace our y with, a or b, which letter, or c or d or e, but it's usually you usually only use 2. It's resolved by working backwards and seeing just what formulas come out, what formulas we get at, working backwards, thinking it backwards, and saying, okay, we need exactly this formula to get this conclusion, right? What's the form of this conclusion? What rule allows you to derive formulas of that form? What formula do you need to make that inference with that rule? Okay, so look at how it goes in the first few steps. We've got the 3, these are all 3 premises, okay? This hasn't appeared, of course. You've got these 3 premises. Negated existential is the second one. You have to CQN on that. That's not I, it'll go to A. First premise, is that a universal? Yes. Scope of the quantifier goes to the end. 3 is also universal, although please pay attention to the form here, right? As I said in the previous example, when you're attending to the form, you really want to really think 2 steps ahead, right? Not only what is its form, which will tell you what rule to use, but also what will be the result of, say, doing a universal instantiation, right? Notice that the result of universally instantiating from 3 will not be another universal, but will rather be a conditional, right? With this as the antecedent, and that is the consequent. Actually, after this proof, she gives you on 348, when she's giving you a few reminders about the importance of parentheses, right here in the book. What she says there is really applicable to doing the result of UIing, doing the universal instantiation on this formula, and seeing that it's a conditional with that consequent, which means if you get the negation of that consequent, you can do a modus tollens, which is sort of what we'll do. But look at these 3, listen to these 3 steps. So this is Klenk, working backwards, step by step, and arriving at each case in the particular formula you need, and letting that determine her next thought. Okay, so right after she presents the proof, the premises, and the conclusion, of course, working backwards is remaining conclusion driven, looking at the form of the conclusion, and here is how she does it. Here, the conclusion, right, so here the conclusion is a universal statement, so, right, it's a universal statement, so we will set up an A flag subproof and then try to derive the instance, this, right? So that's the first step, right? Look at this. What's its form? It's a universal statement. So I'm going to get it by UG, right? UG, that's the hard one. Always hard before easy. Second instantiation of that advice, that strategy advice, is set up for universal generalization before you do any universal instantiations. So I'll set up my UG subproof. It starts there and continues here. Flag A, flagging step for universal generalization. A has appeared in the proof, right? So keep that in mind when we're instantiating, especially if we're existentially instantiating. A has appeared in the proof. You could not couldn't EI to A. You couldn't instantiate to the letter A because you had a flag A. A's in the proof. Doesn't actually matter here because we're not doing any EIs first of all. We can't EI of 2 because 2 is a negation. I hope you will see that. That's going to be very clear to you, which I'm sure it is because you're in Top Gun. But, okay, so And of course, notice that she's applied the thought, which I keep repeating by saying universal generalization is just like conditional proof. It has the same advantage as conditional proof in that you can determine the specific instance, the specific formula you need to end the UG subproof. You can write down, and this is you write flag A, and the very next thing that appears before this, of course, is this, right? This is the next thing that appears on your proof, this particular instance. And then you look at it, you determine its form, and you let its form determine your next move. And that's what she does. It's a conditional, so we set up for a conditional proof. Right? The crucial thing is that you can see in videos or in lectures that you can't really see so well on Klenk's text, unless you're really reading closely in between the lines. The thing you can see is the order in which the formulas appear, right? This one, and we've got this, and then this. You look at that, determines that you put that. That's a conditional, so the conditional comes out. But it's pretty clear how she says it here. Okay, so we set up the A flag subproof, try to derive this instance. This is a conditional, so we will want to assume the antecedent and try to derive the consequent, right? And where does her thought go next? The consequent is an existential statement, which we can get just by existential generalization, provided we have an instance. What instance, right? This is an EG. This is an existential statement. It's that is the propositional function which you EG over, that you existentially generalize from. It's not weird that it's a negation, right? This is just as fine, right? This one now is just as fine a statement as if it didn't have the negation here. It's just as legal a formula as if it didn't have a negation. So there's nothing wrong with adding an existential here with a negation there. And look, by doing the opposite of generalization, instantiation,